Hi, we are on the very last section of Chapter 3. We're on Lesson 6, Parallel and Perpendicular Lines. So we're going to talk about that. We're going to do 2 proofs, and then I think that's it. I haven't gotten any questions yet this week, so bring them to me on Friday if you have any. It is lunchtime, so look out. Okay, that's perfect that it shows up right there. Okay, so first of all, pretty basic, the definition of parallel lines. I'm sure you guys can all imagine what parallel lines look like. Here, my finger, this pen, kind of, those are parallel lines. Now, there are 2 important things that you need to remember when dealing with parallel lines. One is that they're on the same plane. Okay, why is that important? Because if they're not on the same plane, you can't talk about whether or not they're parallel. You can have one line over here and one line here, and they're never going to intersect, but they're not in the same plane, so it really doesn't make a difference. Or, this line going straight at you and this line going right over there. They're never going to intersect, but as long as they have to be on the same plane to talk about them being parallel. Yeah, so those are the 2 things to remember with parallel. Everything's collapsing today. All right. One day I'm going to show you a picture of the counter space that I'm working on. Okay, so parallel. Yeah, there you go. That's my handy dandy way of remembering which one means parallel. But you guys already know that by now. All right, bye-bye parallel. Parallel things aren't nearly as interesting as perpendicular things. That's when it gets exciting. Now, perpendicular things form a right angle. You'll read in the definition in Lesson 6. Why is that important? It is. It'll be useful. So when you see 2 lines come together, like so. Whoa, whoopsies. Then when you are using your proofs, you'll say, okay, let's call this line L and this is line M. Line L and line M are perpendicular, and the way you write that is like this. And they form this right angle. Right? So angle 1 is a right angle. Now, you also wind up learning a few more interesting things because of that. This is the definition of perpendicular, that they form a right angle. However, because you know that, you can imagine working your way to figuring out, okay, well, this is 2 lines, which makes these 2 a linear pair. They have to be supplementary. They have to add up to 180, which means that one has to be a right angle. And then you can do the same thing all the way around. Yeah, that one has to be a right angle, and that one has to be a right angle. So you wind up with the theorem that because of this definition that perpendicular lines form a right angle, that if you have 2 perpendicular lines, it actually forms 4 right angles. So that's the first theorem that you learn about perpendicular lines. And then the only other theorem that's left in this section, so go ahead and read through Lesson 6, Chapter 3, is that all right angles are equal. Okay, so if I have any 2 right angles, and you'll start to see this in a proof, you'll see 2 right angles, and then your brain will trigger, oh, 2 right angles, those are equal. Okay, all right, bye-bye perpendicular. Let's get to some proofs. Okay, first one I'm going to do is, I think, page 108, number 33. Go ahead and look in your books on page 108, number 33. I think this is the one. Why is it not? I feel like it's not. I feel like it's not focusing very well today. I'll work on that. Okay, so page 108, number 33. Yeah, that's what that looks like. Okay, so first of all, whenever you do a proof, you copy down the figure, you write the given, you write what you need to prove. In this case, you're given that angles AYR and angle RYN are complementary. And then you're going to try to prove that AYN equals 90 degrees. Now, the reason I really recommend that you write down your that you copy down the picture and what you're given and what you're trying to prove, especially when you're starting off, is that it really helps you get a sense of what you're trying to do. Later on, you can kind of take some shortcuts and not copy it all down. But when you're first starting, I really think it's helpful because it forces you to look and think about what you're doing before you actually start to do it. Okay. So, of course, in a proof, you always start with what you are given, right? So let's do that. So I wrote down statements and reasons, and I am given that angle AYR and RYN are complementary. I am going to take some shortcuts while I write so I don't keep you here forever. That one's given. 2. Okay, so they're complementary. So what? Let's use the definition of complementary. Okay, this should tell us something. And the definition of complementary is that complementary angles, I guess the measures of complementary angles have a sum. Wow, I didn't word that well at all. You can look in your book and come up with something more succinct. Perhaps the sum of the measures of complementary angles is 90 degrees. That sounds a little nicer. Okay, so let's use that. Let's use that definition since we know that they're complementary. Okay, so they have a sum of 90 degrees. Let's go ahead and say that. Okay, that seems pretty good. Now, from there, we are trying to get to AYN being equal to 90 degrees. So as you do this, you need to think about where you're headed. So if those are equal to 90 degrees, now the only thing that I would really rather have here is the betweenness of, did I miss a given? Aha! I knew it. Okay, I knew this was missing something because, there was a second given in this one, which was that YA, YR, YN. I knew it. I knew something wasn't working there. Now, let's go ahead and use that next given. Okay. YA, RYN. That one's given. Now, this should scream at you something, right? Something should shout out at you. And that thing is the betweenness of Ray's theorem. And what does that say? It says that when you have 3 rays in a row, all with the same vertex of y, then that angle plus that angle equals the total angle. All right, so I'm going to go ahead and write that as AYR is the first angle, plus the second angle is RYN equals the entire angle AYN. All right, excellent. Now we're getting somewhere. And now, ooh, look at that. AYR plus RYN, I have the same thing up here. So if that is the same as that, then that must be the same as that. So there you go. AYN equals 90 degrees. And what did I do there? I substituted. So substitution would be the reason for that. Okay, so that's your finished proof and kind of a way to think through it. We are done with that one. And now we have one more that I wanted to prove. And I wrote it down. Let's see. Okay, so this one is page 114, number 28. So go ahead and go to page 114. And then my collapse, I had lost it before. Okay, number 28 is this quadrilateral heke. Oh, it's kind of fish. Were they all fish on that page? Ah, they were. I didn't even notice that till right now. All right, so let's talk about how to prove this. Yeah, wow, okay, that's funny. So this is going into the future a little bit. This is the end of lesson 6 in chapter 3. But I wanted to just do it because we're going to be working on set 2 in class on Friday. Okay, so in this, you're given this quadrilateral hake, and you're given that HE is parallel to EK, and that HA is parallel to AK, even though it doesn't really look like it in my picture. And you're trying to prove that angle E is equal to angle A. Now, I think this one's going to be pretty easy. You always start, you put your statements and your reasons, and step 1, you always start with your given. So let's do that. Let's start with this and see where it takes us. Okay, so that one is given. Okay, so you have just been given 2 sets of parallel lines. So that should tell you something, that if you have 2 parallel lines, then they form a right angle. Okay? I'm sorry, perpendicular. Sorry, have I been saying parallel? Okay, I told you I was hungry. Okay, so 2 perpendicular lines form a right angle. Okay, so that means that I'm going to call angle from this, HE and EK, you know that angle E is a right angle. And from this, HA and AK, you know that A is a right angle. So angle E and angle A are right angles. Oh, thanks, darling. So you know that angles E and A are right angles. And the way you know that is because 2 perpendicular lines form a right angle. Okay, go talk to Keegan for a second. I'm almost finished this, and then I can help you. Okay. Okay. Hi, Ingrid. You want to say hi to the class? Hey, Keegan, come get Ingrid. Okay, so angles. So those 2 are right angles.
You're talking to no one.
I'm talking to no one. Yes, I'm talking to myself. I'm teaching a class. Give me just a minute and I'll come help you, Ingrid. Okay, so E and A are right angles, and I'm trying to prove that E equals A. Okay, so how am I going to do that? Well, because it's a right angle, that leads to the very next obvious step, which is that the measure of E equals 90 degrees, and the measure of A equals 90 degrees. And how do I know that? Well, I just use the definition of right angles. So I'll write over here, right angles have a measure of 90 degrees. Good, and then it should be pretty obvious that you're there, that if that's 90 degrees and that's 90 degrees, then they have to be equal to one another. And the reason why is because that's the same as that, so you can substitute in. Okay, so that's your finished proof there. I hope this is helping you. You guys did a really good job in class on Friday of working through proofs and building on top of each other. I know you might not realize it, but I can see tremendous progress. So in addition to finishing that set 2 from lesson 5, I'd also like you to do set 1 from lesson 6. I will include that in the email that I send out. Okay, enjoy the rest of your week and see you on Friday.